There's a certain kind of wonder that lingers when thinking about dinosaurs, a quiet fascination that can grip you at the oddest moments. Maybe it's the sheer scale of their lives, or the way they dominated Earth for over 230 million years. But sometimes the mind drifts to one of the strangest mysteries of all, with all their success. Why did no dinosaurs ever fully take to the water? It's a question that pokes at the edges of logic. Surely, among tens of thousands of species, some must have made that leap, right? But when you look closer, the truth is clear. Not a single dinosaur spent its entire life submerged. Everything that seems like a water dinosaur is really something else entirely, a marine reptile. Distantly related, swimming under its own rules. Dinosaurs, for all their dominance, stayed largely terrestrial. And yet, the idea of them in water is tantalizing. Look at birds today, the closest living relatives of dinosaurs. Many of them live in or on water. Ducks, pelicans, swans, gulls, some, like penguins, spend half their lives in the sea, diving and chasing fish with uncanny grace. Others, like the wandering albatross, soar above the waves for years without touching land. These birds offer a glimpse of what dinosaurs might have approached. Over time, they evolved special adaptations: webbed feet, beak shapes tuned for aquatic diets, salt glands to drink seawater safely, but even then, they never became fully aquatic. Even the Hesperorniths of the Cretaceous, the early seabirds, only came close, skimming the surface and diving for fish without abandoning land entirely. Non-avian dinosaurs flirted with water too. The spinosaurids are the poster children for semi-aquatic behavior: large theropods with nostrils set back on their skulls, cone-shaped teeth perfect for snagging slippery fish, and tails possibly adapted for swimming. Fossil evidence places them near rivers and lakes, hinting they spent significant time in the shallows. But even these giants didn't dive fully into the aquatic world. Smaller, less famous species like the housecar tiny, raptor-like dinosaurs, with flipper-like forelimbs, short tails, and sensitive snouts suggest similar experiments in semi-aquatic life. Their teeth curve backward, ideal for catching small fish, and their bodies hint at adaptations for swimming, and yet, these experiments never fully crossed the line. Other curious cases pop up in the fossil record. Early Cretaceous dinosaurs, like Luffingosaurus and the incisor Leoningosaurus, showed hints of water-friendly traits. Luffingosaurus, heavy and stocky, may have lingered in rivers munching aquatic plants, while Leoningosaurus, small and oddly built, suggested a semi-aquatic lifestyle. Later research, however, showed that Leoningosaurus fossils were likely juveniles that drowned, a reminder that nature rarely gives clear-cut answers. Still, these cases offer a window into what might have been. Why, then, did no dinosaur become fully aquatic? Part of the answer lies in competition. The oceans were already ruled by predators like ichthyosaurs, plesiosaurs, mosasaurs, and large crocodiliforms. Freshwater ecosystems had fish, amphibians, and phytosaurs. Any dinosaur venturing fully into water would have faced fierce, well-established rivals. On top of that, there were biological barriers. Dinosaurs laid eggs, rigid shells made for breathing air, not water. Place them underwater and embryos risked drowning. Some snakes evolved live birth and conquered the seas, but dinosaurs never did. Hollow bones, so useful for balance and flight, made diving challenging, adding yet another layer of difficulty. Even evolutionary trends: the shrinking arms of theropods, robust weight-bearing limbs in ornithischians pushed them away from aquatic adaptations. And size mattered. The average dinosaur weighed almost 4 tons. Evolution tends to favor smaller animals for aquatic transitions. Still, the post-KT world offered a fleeting opportunity. With most large marine predators gone, a gap opened, waiting for a bold lineage to seize it. Mammals, smaller and viviparous, moved in quickly. Dinosaurs had already vanished, leaving birds as the only remaining heirs, but even they were only halfway into the water. Speculating what a fully aquatic dinosaur might have looked like is both thrilling and humbling. Imagine a spinosaur or a tyrannosaur with smooth, hydrodynamic skin, paddle-like flippers, and a vertical tail fluke, slicing through the water like a living torpedo. Herbivorous species could have adapted to graze seagrasses, evolving defensive structures into elegant, streamlined forms, taking cues from the modern swordfish or sawfish. Or perhaps some would have retained limbs, moving slowly along the sea floor, prioritizing size and resilience over speed. The possibilities are endless, yet grounded in the subtle rules of evolution. In the end, the story of dinosaurs and water is one of near misses, evolutionary experiments. Under quiet power of constraints, Earth's oceans were already teeming with life, their currents and depths shaping every niche. Dinosaurs thrived on land, mastered the skies, but never quite conquered the deep. And maybe that's part of their enduring magic. They remind us that even the most dominant creatures face limits. Today, we see birds dipping their wings into lakes and oceans, hinting at what might come, and as we watch seals, whales, and penguins glide through water, we can't help but wonder what could have been. Had dinosaurs taken that final plunge?